Hi guys, Dr. B here. This is topic 1.1, moles and molar mass. It should be a simple topic um, because it's only going to get worse from here, so FYI. So the learning objective is to be able to calculate quantities of a substance or its relative number of particles using dimensional analysis and the concept of the mole. Remember that in 1 mole, it is Avogadro's number of whatever we're looking at. So particles, formula units, we're going to talk about that. Donuts, whatever. So it's impractical to count all the atoms because they're so small. So we use conversion measurements to be able to make those numbers into something that we can use. Atomic masses are measured in atomic mass units, AMUs. So it's based on the carbon-12 isotope. So like the 12 grams per mole of carbon, like that. That's like atomic mass, molar mass, etc. So how to calculate molar mass? Pretty simple. You recognize how many atoms you have of each atom. So like in this N2O2 dinitrogen tetroxide, you have 2 N's and 4 O's. So 2 times the molar mass or atomic mass of nitrogen, 14.01, is 28.02, plus 4 times 16, that equals 92.02 grams per mole in the end. Like we did before sophomore year, you can use a molar mass as a conversion factor in order to be able to convert between moles and grams. Avogadro's number, 6.022 times 10 to the 23 particles per mole, is a conversion factor. You can use that to convert between numbers of particles. So the particles can be molecules, atoms, formula units, ions, and moles. And we'll see a couple examples with formula units and ions so you can know what I'm talking about. I don't know if you can hear my PS5 in the background though. Just all right. How many moles of lead 2 iodide PbI2 are there in a 25.0 gram sample? So you can kind of see on the bottom I put the calculation for it. I'm testing that out. So let's see. So you're just going to do some dimensional analysis. 25.0 grams of PbI2 So in 1 mole of PbI2, it is the molar mass of PbI2, so 461 grams of PbI2, which you should be able to calculate. To your calculation, remember that double slash like that means equals, so you end up with this number down here. So then remember sig fig rules, 3 sig figs, so 3 sig figs, 1, 2, 3, should be 0.0542 moles PbI2. So remember your math. You multiply across 25.0 divided by 1 times 461, like that. You divide those two numbers, call it a day. How many atoms of lead are in the sample? So you are going to take, well, first of all, we're going to use our answer from the previous question. So just use the number that we have for the final answer, 0.0542 moles of PbI2. Notice though, it's asking for the atoms of lead. And we only have PbI2. So you have to kind of create a mole ratio based on how many you have of each element in the compound. So what does that mean? So in 1 mole of PbI2, so the idea is you look at the number of ions of each ion in your formula. So you see you have 1 lead and then 2 iodines. So in 1 mole of PbI2, there is 1 mole of Pb. If it were asking for the atoms of iodine, you would use 2 moles of iodine. So 1 mole of lead, it is 6.022 times 10 to the 23 atoms of lead. Double slash. So you just multiply across, and there's all these ones, so we're good. So 0.0542 times 6.022 times 10 to the 23 equals 3.26394, blah, 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 E22. So remember, E22 is times 10 to the 22. We had 3 sig figs. So 3.26 times 10 to the 22 atoms of Pb. A 0.24 gram sample of calcium carbonate was recovered from a sample of hard water. How many formula units of CaCO3 were in the sample? So a formula unit, basically it's saying how many CaCO3s are there together as a formula. So you're going to take your, I'm going to use that line for me, 0.2444 grams of CaCO3 over 1. You want to get to formula units. So in 1 mole of CaCO3, it's the molar mass, which is 100.09 grams of CaCO3. On the next one, so in 1 mole of CaCO3, so it'd be kind of hard to abbreviate formula units if I put FUs, so I'm not going to do that. So 6.022 times 10 to the 23. I'm going to write out the actual word formula units CaCO3 double slash. So 0.244 times the 0.244 times 6.022 times 10 to the 23 divided by 100.09, you end up with this number down here. So 3 sig figs. 1.47 times 10 to the 21 formula units. Ew, that's bad. CaCO3. All right, that's it for now. If you have any questions, please let me know. Hit the like and subscribe and all that type of stuff. Bye.